Boston Dynamics just revealed new footage of its Atlas robot, and this time, it's moving in a way that looks almost human. At the same time, humanoid robots in China are now performing complex kung fu movements alongside real martial artists. Entire groups of robots are beginning to perform synchronized shows with stability that didn't exist before. And now, companies in the US are starting to actually sell humanoid robots with real prices, delivery timelines, and real-world use cases. This is no longer just research. This is starting to become real. Let's start with Boston Dynamics, because what they just showed with Atlas is one of the clearest signals of how far humanoid robotics has come. In the latest footage, Atlas doesn't just move, it flows. It begins with something simple, walking across an open space. But even that feels different now. The posture is upright. The movement is smooth. There's no stiffness, no hesitation. It looks controlled, balanced, almost natural. And then, within seconds, everything changes. The robot launches into a full cartwheel. Not slowly, not awkwardly, but with coordination between arms and legs that keeps momentum stable throughout the entire motion. That motion transitions directly into a backflip. Atlas tucks its body mid-air, rotates cleanly, and lands on both feet. And the landing is what really stands out, because it doesn't crash down. It absorbs the impact. You can actually see how the force moves through the legs and torso, distributing pressure in a way that looks intentional. And that's where the difference is. This is no longer a robot executing a pre-programmed sequence. This is a system responding in real time. There are moments in the extended footage where Atlas fails. It stumbles, it missteps, it loses balance. But instead of shutting down or freezing, it adjusts. It corrects itself mid-motion, it recovers, and keeps going. Those small corrections might not look dramatic, but they're actually one of the most important parts of the entire demonstration. Because real movement is not perfect. Humans don't move perfectly. We adjust constantly without thinking, and now, robots are starting to do the same. This level of control comes from a learning system that doesn't treat each movement separately. Walking, jumping, flipping, these are not isolated skills anymore. They are part of a unified control system, a whole-body learning approach. That means the same system that allows Atlas to walk smoothly is also responsible for those complex gymnastic movements. And that's a major shift. Because one of the biggest challenges in robotics has always been transferring skills from simulation to reality. You can train a robot in a simulated environment, but when you move it into the real world, everything changes. Friction changes, balance changes, timing changes, and most systems struggle to adapt. But what Boston Dynamics is showing here is something different. A level of transfer that actually works, where behaviors trained in simulation can be applied directly to a physical robot. And that removes one of the biggest bottlenecks in robotics development. But here's where it gets even more important. Because this version of Atlas is not just for demonstration, it's part of a transition. From research to real-world deployment. The production version of Atlas is being prepared for industrial use, and companies are already planning where it will go. Factories, warehouses, manufacturing lines, places where physical work is repetitive, structured, and scalable. The robot itself is designed with multiple degrees of freedom, advanced sensing, and precise manipulation capabilities. Which means it's not just moving, it's handling objects, interacting with environments, completing tasks. And once that happens, the question changes. It's no longer, can robots move like humans? It becomes, what happens when they can work like humans? Now, while all of that is happening in the US, something equally interesting is happening in China. Because over there, humanoid robots are being pushed in a completely different direction. Instead of focusing only on industrial tasks, companies are exploring expressive, dynamic movement. And one example of that is robots performing kung fu alongside real martial artists. At first, it looks like a demonstration. But when you look closer, you start to notice something else. Balance, speed, timing. These robots are not just mimicking movement, they are coordinating it. They perform sequences that require precision across multiple joints, maintaining stability while executing fast, complex motions. And what makes this even more interesting is how they are learning these behaviors. Instead of relying entirely on pre-labeled data, some of these systems use visual input to infer movement. They observe, they interpret, and then they replicate. This approach allows them to generalize, to take what they see and apply it in new situations. And that's a key step forward. Because one of the biggest limitations in robotics is the lack of high-quality training data for human-like movement. Humans move in complex, unpredictable ways, and capturing that in data is difficult. But systems that can learn from observation begin to bypass that limitation. And that opens the door to faster development, more flexibility, and more adaptability. Now from there, things scale up even further. Because it's not just individual robots anymore. Entire groups of humanoid robots are starting to perform together, in coordinated sequences, at events, on stages, in environments where timing, synchronization, and stability all have to work at once. And this is where things start to feel different. Because it's one thing to see a robot perform a single action. It's another thing to see multiple robots operate together without breaking. Maintaining coordination over extended periods. Handling transitions between movements. Adapting in real time. That level of stability is what separates demonstrations from systems. Because once robots can operate reliably in groups, they become scalable. And scalability is what turns technology into infrastructure. Now, while all of this performance and coordination is being developed, something else is happening at the same time. Companies are starting to sell these robots, not as experiments, not as prototypes, but as products, with prices, with delivery timelines, with use cases. And that changes everything. Because once a technology becomes something you can buy, adoption begins. And when adoption begins, competition follows. Different models are being introduced. Some designed for commercial environments like retail, hospitality, and events. Others designed for industrial tasks. Some focused on interaction. Others on physical capability. And they come with different levels of functionality. Perception systems. Language interaction. Navigation. Task execution. All packaged into systems that are meant to operate in the real world. And this is where the shift becomes very clear. Because this is no longer about whether robots can exist. They already do. It's about how they will be used, and how quickly they will be integrated into existing systems. Because once companies see efficiency gains, adoption accelerates. That's how technology spreads. Not slowly, but through competition. And when one company starts using robots to reduce costs or increase output, others follow. And that creates a chain reaction. Industries begin to change. Workflows begin to shift. Roles begin to evolve. And this is where everything connects. Because on one side, you have robots that can move like humans. On another, you have AI systems that can think, plan, and execute tasks. And when those two come together, you get something entirely new. Not just machines, but systems that can perform work. Physical work. Cognitive work, or both. And that's the direction everything is moving toward. A combination of intelligence and embodiment. Where AI is not just software, and robots are not just hardware, but together they form systems that can operate in the real world. And once that happens, the impact goes beyond technology. It affects jobs, it affects industries, it affects how work is defined. Because when machines can perform tasks that were once limited to humans, the structure of work begins to change. Not instantly, but gradually, and then all at once. Some roles become more efficient, some become less necessary, some disappear, and new ones emerge. But the transition is not always smooth. Because while technology evolves quickly, adaptation takes time, and that creates tension between what is possible and what is ready. And that's where we are right now. at the beginning of a shift, where robots are no longer just demonstrations. They are becoming systems, products, workers. And the real question is not whether this will happen. It's how fast it will happen, and who will be ready when it does.